In my previous video, I mentioned that I want to develop graph augmented knowledge base on top of my already existing full text search and vector based search. I'm fairly happy with the vector and full text search. It's really good for technical documentation. But when you want to go into more unstructured documentation, it falls apart a little bit. And so, for instance, I took the subtitles of Criminal Minds, all 363 episodes, and loaded those into vector and full text search. And there's really good questions you can ask from that, and it will answer them. But it's really difficult to get any deep information out because it's subtitles. Subtitles don't tell you who's speaking. They don't describe the scene. They don't. There's a lot of it missing. But in the case of Criminal Minds, is what I could find, right? And so when you ask it for questions like which episodes did David Rossi appear in, forget about it. Because the vectors and the full text search is like top 5 hits, or if you ask it which episodes have a female offender, you're out of luck because, again, it just doesn't work. And that's a problem I want to solve. These kinds of questions out of completely unstructured data. And so the idea is that you're going to take the data set up front, decide what you want to extract out of it, and potentially also do some maps. Here we say often they refer to Jennifer as just JJ, so we do some maps of names and so forth. And that is what I've designed, the way to extract this data, the way to index it. It's all going on SQLite, the way to steer the thing, the way to have different parts of your corpus of data with different keys in it. SQLite schemas and so forth. All of these kind of things have been designed. And we did a POC where I walked through one season, season 16, I think, and one episode from season 2 to see how this is going to shake out. So turn some of these nodes off here. And here's a character graph of who, wrong direction, of who was in those episodes. And so we can see, all of the kind of one-offs, the kind of side characters and extras and stuff like that. Here we have Zacharias. He's obviously going to become a big character, but he's essentially a different person from Elias Bolt. And so we can go in and we can say, filter down to frequency, and we get the main character set. And these are the main characters that's in most of your episodes and stuff like this. And I can say by crime type. Obviously this series has a theme. It's homicides, abductions, and serial killers, right? The cities that they play off in. Let me just zoom in a little bit here. There we go. The state outcome is, they've got the guy. He died, escaped, or unresolved. There's the void story goes on for a long time. Themes are open-ended. I just asked the LLMs to pick out the themes. How many unsubs there, multiple of one, and finally the gender. From this data, I can now ask those questions that I showed as problem space. I can ask how many female unsubs were there. I can ask, list me the episodes. I can say, give me the summaries of the episodes. I can ask, give me all the episodes with a certain character in it, etc., etc. The limitation, though, is I can only ask it what I ask it to index, right? So you have to really think about your corpus up front, and then index it and create this data, and then you can run your queries. Now, the input data is just horrible, right? If we look here, Criminal Minds episodes, this is how it looks. This is literally just subtitles, really bad, and often it will even split if there's a D.C, Washington DC. It will just split it across two lines. I don't know what's going on with this, but this is what I could find on the internet, and from this quality of data, really bad, really terrible quality, I was able to extract quite high quality relations and so forth. And that's because I was running it into a local Quen 35 billion model, and just that's the vector embeddings. But the Quen model locally was doing the summarization and the extracting of the the contents, the male or female, all these kind of things. And it goes into SQLite, and then I can ask LLM questions like that. And this is, to me, is kind of the worst case scenario as data goes. Like, this is the worst, just random text, no headings, no sections where you can chunk, none of this kind of stuff. And I'm quite encouraged by the level of details that I can get out of this data, and the questions I can ask from the data, even when it's like that. And so I hope to land that into my RAG system, that you have these 3 layers of knowledge, and you can opt into vectors and graph as you wish. But they will be always single binary, no extra dependencies other than the models. There's no, you don't need to run Neo4j or anything like that. This should be sufficient for thousands of documents locally. So, an extraction of issues of GitHub and project documentation and all this kind of stuff. There should be no problem at all to index that and get really good quality questions and answer sessions out of that data, with no extra installations, just first binary, and you're good to go. Anyway, that's it. Just wanted to show the progress I made around graphs and extracting sense out of just rubbish input data. Thank you.